In this video, I'd like to talk about a special product of polynomials, specifically what are known as perfect squares. So a perfect square is when you have some binomial, let's say a plus b, and this binomial is squared. So if we wanted to find a formula for this, we could multiply this out. And when you have some binomial squared, you need to rewrite it twice so that we can multiply it out using distribution. Now, one very common mistake with these is that students will think this is equal to a squared plus b squared. So this is very common. Students do this all the time. So you need to be careful not to just distribute this square because that's not what it means to square something. Remember, when you have something squared, let's say 4x, then the square just means we need to take this and multiply it twice. So that's 4x times 4x, and of course you get 16x squared. So with multiplication, you do in some sense distribute the square to each of the factors here. But with addition, it's much more complicated. So you need to be careful. And if we rewrite this twice, we get a plus b multiplied by a plus b. And to multiply these two binomials together, we need to use distribution. So the a will multiply to both terms here, and the b will multiply to both a and b and the second binomial. So a times a, that's just a squared, and a times b, we'll write that as plus ab. Then we get the b term multiplied into each. So we get b times a, which we can just write as a times b or ab, since multiplication is commutative, the order can be flipped. And then we get b times b, which is just plus b squared. And with these perfect squares, notice that the middle term is added twice. So plus ab, we can actually just rewrite as a squared plus 2ab plus b squared. So this is our formula for multiplying out these perfect squares. And if you want, you can just use the formula where you can label this as a and this is b and just plug in a and b into this formula here. Since we know we have this a plus b squared and a is 6y squared, we can just plug them in here. So we get a squared, so that's 6y squared, and we're going to square that. And we get plus twice a, which is the 6y squared, multiplied by b, which is 5y to the fourth. And then lastly, we square b, which again is the 5y to the fourth, and we're squaring that. And then we just simplify everything. So 6y squared squared, we're multiplying this twice, so we get 36, and y squared squared is y to the fourth. If you have an exponent and you raise that to an exponent, you just multiply those. Or we essentially have y squared twice. So y squared times y squared, and so that's how you get 4 of those. And then here we can multiply all the number terms together first. So 5 and 6 make 30. 30 times 2 is 60. And then y squared times y to the fourth, we've got 2 y's here, 4 more there, and so in total we have 6 of them. And then lastly we have 5y to the fourth squared, so we could rewrite that twice. 5 times 5 would give us 25. And y to the fourth multiplied by itself, so y to the fourth times y to the fourth is really just y to the eighth. So this should be our final answer. And using the formula is one method to achieve that. But we could also just multiply this out by hand. So that's a good way to check this problem. So let's first start by rewriting it. We have the 6y squared plus 5y to the fourth, and we're squaring that. So when we're squaring a binomial, remember we just need to rewrite it twice. So 6y squared plus 5y to the fourth multiplied by itself, 6y squared plus 5y to the fourth, and now we will use distribution. So 6y squared goes to both, the 5y to the fourth goes to both, And 6y squared times 6y squared we know is 36y to the fourth. And we get 6y squared times 5y to the fourth, so that's going to be 30y to the sixth. And notice we get that same product again, it's just reversed now, but 5y to the fourth times 6y squared, that is also 30y to the sixth. And lastly, 5y to the fourth times 5y to the fourth. 5 times 5 is 25. Y to the fourth times y to the fourth is really y to the eighth. And notice that if we add the two middle terms together, since they each have a y to the sixth, so it's like having 30 y to the sixth, and we're adding 30 more of that same amount, then you really have 60 of those. So this does simplify back to what we found with the formula. And using these two different methods just gives you a nice way to check your work, but in reality you could just use one. But if you do need to know for sure if it's a correct answer, then I do encourage you to use both different methods here.